Hi, everybody. I'm waiting two people, and there is no message on the Discord. They are coming or not coming. I don't know.
Yeah, we can wait for another 1-2 minutes, I guess.
Sorry, I cannot hear totally again.
I guess we can wait for another 1-2 minutes. And
Okay.
then we can start.
Okay.
Which provides a spherical foundation for the subsequent measurement. When the Hadamard gate is applied to an auxiliary qubit, the amplitudes are copied into both states. This step helps to spread the amplitudes within quantum superposition, thus enabling access to more information. Also, the decrement gate is used in the Q-head algorithm to option gradient information by shifting the position of amplitudes. By shifting the amplitude of each pixel relative to its neighboring pixel, it allows us to calculate the difference between these neighboring amplitudes. This process enables the amplitudes to be shifted in a specific pattern, which also helps to compute gradients more clearly. The decrement gate is a unitary operation composed of X gate and CNOT gates. An image explain this. And final steps, Hadamard gate on auxiliary qubits and measurement. When applied to an auxiliary qubit, the Hadamard gate allows the addition or subtraction of neighboring amplitudes. It adds amplitudes for even states and subtracts them odd states. This enables the representation of gradient information in the quantum state. The measurement focuses on the difference between neighboring amplitudes. Amplitude difference represent pixel gradient difference. Larger gradient difference are associated with higher measurement probabilities. The desired gradient information is optioned with the odd state, and the number of measurements can be plotted according to pixel positions. Thanks for listening. Also, could you please explain can you share your opinion also there?
Okay.
I have with the Simges this week.
Yes.
There's no problem with that, right?
Yes.
Okay, I think the method found by Simges will work, and I agree with her. In this article, classical detection methods were used when detecting edges. We can also develop this algorithm by using Harris corner algorithms and gradient difference. By taking advantage of this edge detection, we can use that. I think so.
Yes, it's feasible, I think, and yes, we can continue with this method. And did you test the code?
So we are trying to implement this quantum Hadamard edge detection technique using this QPI encoding method.
Yes.
And here the main thing is that we have to kind of bring the Harris corner detection classical algorithm into this framework. So currently, if we see here what they do, they just compute if we see equation 2.6, they just compute the derivative or the difference of the adjacent pixels, C0 plus C0 minus C1, C1 minus C2. So this is maybe good for detecting edges. But if you want to detect the corner using this method, we have to bring this Harris corner detection scheme, because in the Harris corner detection scheme, we compute the gradient using a particular window of some size. So we can use this algorithm, but we have to modify it significantly so that we can bring the Harris corner detection here, and then we can detect the corner. The advantage here that we are getting from the paper which was there, this quantum fast corner detection, is that in the quantum fast corner detection, they were using some naive circuits like subtractors, comparators,
Yes, yes.
and they were using this classical or digital system design where they have all this comparator, adder, and subtractor. But in the quantum, uh, this is not like a very good analog to bring all this into the quantum and then do the computation. This may be like uh, too much to do. In the classical, we already have a lot of good algorithms or a lot of good hardware that can easily do those kind of operations. So in quantum, if we want to do parallelization, then we can use this Hadamard gate. So I think this is a good idea that we can pursue. And also this quantum Hadamard edge detection, this one is mainly for the quantum probability amplitude encoding. So if we see here, so this is mainly designed for the QPIE, but we can also modify it for the other encoding methods such as this FRQI and NEQR by doing some transformation here in the amplitude. So this amplitude can be converted into in the cosine function. So the cosine of theta, where theta will be the cos inverse of the amplitude. So in this way, I think we can use different encoding methods, and we can use this Hadamard technique to implement the Harris corner detection scheme in quantum and then get the output.
Did you think it can be implemented by loading method QBIP binary method?
I am not sure about the QBIP
Yes.
because that encodes in the Boolean. So if we encode in the amplitude, because if we see here in equation, let me go there. So the main thing is this equation 2.3, or I was showing 2.6. So let me go to, yeah. So equation 2.6 is the main thing. And here the 2.6, it shows that the gradient is actually stored in the amplitude of the state vector. So I'm not sure about the QBIP, but wherever we encode the image intensity or the image pixel in the amplitude, then I think there we can use this technique to kind of implement this Harris corner detection scheme. And for the data set which you mentioned, this handset data set of the shapes, rectangle, ellipse, and triangle, I think for those cases, Harris corner detection will be a good fit. It doesn't require a very high-end kind of a classical corner detection scheme. I think Harris is good. And this Hadamard will really help us to kind of get around those circuit complexity which was there in that paper, the earlier paper.
Okay. Thank you for your effort and for your suggestion paper, and it's good work. Thank you. This group can continue this paper, and yes, I agree with you. And also, we can continue other groups what did this week, and after we can decide what will follow way. Okay. Second group, Gabriela and Batuan.
Hi.
Hello, everyone.
So this week we focus on understanding the origin of corner detection paper
Yes.
and also how it works. Because I actually messaged you, it was a little bit hard to understand how the auxiliary images were created, but I believe that we managed to understand how it's created, and it is actually, they use it in the superposition to consider the advantages. So what they do on the paper is to save all of the nucleopixels and the circle around it, so you can calculate it. And that's basically where we managed to stop here. We implemented the NRQR, adapted to it. So now we implemented NRQR that encodes all the 17 image, the nucleus image, and all of the 16 auxiliary image presented on the paper. And so technically, we're only missing the more known circuits, the subtractor, the adder, and the comparer, which I believe it would be simple to implement. I think the hardest part was understanding how the images were encoded. And I believe that we managed to understand it. The paper wasn't very clear, but I think we managed to understand how it works and implemented it. It's on the GitHub. I uploaded the circuit, so that's basically our progress this week. We couldn't manage to do too much because we took a long time to understand the paper, but basically that's where we stopped. We have all the images encoded, just needing to do the rest of the original algorithm.
Okay, thank you for your efforts. And yes, I know in the first corner detection paper, and only use a small image. Maybe size of the images is so small. Yes, I agree with you. There is so computational part, and so so many gates are used in this paper. Yes, maybe all of us continue with the Simge's finds paper. Yes, last group, Emre, we can continue with you.
Yeah. Let me share my screen with you.
Yes.
There we go. So, as it sounded to me, it sounded to me like that there are certain problems understanding the circuits, especially the subtractor, the comparator, the adder. And what I've done is that I've focused myself on these things this week. So, basically our goal is to make a comparison of different quantum image loading techniques using QFCD. We are already familiar with all those techniques, NRQR, FRQI, etc. But what causes problems for us is the algorithm, how the algorithm works. And according to the paper, we have to do some preparatory work, like to represent the image in using some image loading technique, in this case NRQR. But we also have to implement some helper circuits, so to speak, like quantum adder, comparator, and post subtractor. And what I have done is I've focused myself on designing the circuit, the quantum post subtractor, and let me show it to you. So here's the basics of building such a quantum post subtractor. Here you can see, and this is from the paper, by the way. Here you can see a 1-bit quantum post subtractor. A is the minuend, B is the subtrahend, and C is the borrow information, the borrow bit. And S is the auxiliary qubit, which we use to store the borrow bit during the calculation. Here you can see the 3-bit version of it. And here you can see the mathematical representation. And what I have done is, so I took this as a basis, applied first principles thinking, and tried to to build up from scratch, from first principles. And what I've done is I designed a 6-bit quantum full subtractor, which worked. I tested it with one example computation. So I tried to calculate 27 minus 21. Here you can see the binary representation of these two. So this is 27, this is 21. We subtract these two. Here you can see the calculation. And at the end, we get the result 110, which corresponds to 6, just 110. So the circuit works. And my agenda, my plan for the coming weeks until our next meeting is to design the quantum adder and comparator, and afterwards proceed with the next steps towards implementing the QFCD algorithm, so that we can be able to compare the results of different quantum image loading techniques. And as you can see, we are going to need those things, like here, the subtractor, the adder, and the comparator.
Thank you. Thank you for your efforts also. And yes, I don't, firstly, yes, everybody know that 2% not attending the group working, and also and Emre is have to work alone, and I decided if you appropriate for you, all of you, and also they I think include the Simge's group to also for also they, and Emre if you want, and Gabriella and Batuhan, if you want 3 of you and working together and for corner detection parts, and if there is no problem with all of us, we can divide 2 groups. Is okay or not okay? I don't know.
Yeah, it works for me. I can work with Batuhan and Gabriella.
Yeah, it's okay for me too. No problem.
Yeah, me too. It's okay as well.
Okay, thank you. And also, yes, I know, Emre, you work very hard and you implement some part of the fast corner detection paper. But I think there is so computational part, as I said before. And if appropriate, all of you, and we can continue Simge's group's paper. And if you want to continue with fast corner detection paper, yes, you can follow. And I suggest all of you Harris corner detection algorithm, and to realizing fast this part of the project. And after that, we can continue machine learning part, maybe 2 weeks later. And so later we start writing and also implementing machine learning parts. I think this routes. Okay. Yes.
I just have a question.
Yes.
So now we're only 2 groups. So what encoding will we use? We'll only use NRQR and QFID, or we still use all the 4 encodings? I'm just question about it. Like now that we're just 2 groups, what is the plan now for we to go forward?
Yes, maybe we can introduce in the second method part of the paper all of the loading parts, and we can explain, yes, Harris corner detection part, we can choose only 2 loading images method because it's feasible. We can say that in the paper. And after that, we can we can explain the loading imaging, how we can load the image, and what is the minus and plus side of these methods. And after that, we can continue corner detection parts and why we choose this method and fast corner detection plus and minus site and other Harris corner detections algorithm plus and minus sites like that. And I think we can do that. Yes, I know fast corner detection. Firstly, before start this project, I think we can use all of the loading imaging models, but as we see that fast corner detection, so many computational parts, and especially machine learning. For machine learning, it's not feasible, I think. I suggest your group continue with Harris corner detection part algorithm. Yes, I know all of your efforts for this algorithm. Sorry for that, but yes, it can be implementable, but it gets so many time. Maybe we cannot finish on August end of this QIntern program. So we should continue Harris corner algorithm, I think.
Okay, thank you.
Thank you. But if you trust yourself, yes, we can do that. You say we can realize this fast corner detection, and you can continue.
No, I'll use the Harris. I just wanted to understand, like, if we're gonna use only two encoders, but from now on.
Yes,
That
there
it?
is also GitHub codes, and yes, it's helped all of you, I think.
Okay,
Codes. Okay.
Can I add one thing?
thank you.
Yes.
So I can see on the ClickUp that Gabriela, Batuhan, and they were doing this AnyQR, and then Amre and Akash, they were doing FRQI. And now since the group is merged, so I have seen a paper that uses this FRQI encoding method, which Amre was using. So I can share that paper that uses this quantum Hadamard edge detection with the FRQI.
Mhm.
So maybe Gabriela and the group, they can work on that paper and it can be helpful for the FRQI. If I find anything about the AnyQR, I'll try to share it on the Discord.
Okay. Okay, thank you. And I have to read this Hadam this model, and we can decide what we should do. I will share the route tomorrow, all of you.
Okay, thank you.
Okay. Thank you for sharing. Is there any question? Okay. Next week, see you.
I have a question,
Yes.
just very short. Could you write on Discord like what everyone has to do? Because maybe there are some misunderstandings, and one description could clarify it. Maybe could you write it on Discord?
Yes, we can continue on Discord because I have to read the documentation, and after that we can decide what is the route, what should be route.
Okay, thank you.
Okay, thank you. Is there any question?
From my side, there's no question.
Yes.
Thank you very much for your additions.
No problem. Thank you for your efforts, all of you, again. And see you next week. Is there another question? There is no another question. Okay, see you next week, and we can continue discuss on Discord, and other 2 person is not attend the meetings and groups works, and we cannot continue with 2 person. Okay, all of you agree with that?
Yeah, no problem.
Okay,
I'm okay.
okay. Thank you. See you next week.
Have a nice weekend too. Bye.
Bye.
Bye bye.
Bye bye.